Hello everyone, welcome back to the AI Academy's Python for Data Science course. In this lecture we are going to look into visualization of data. In our last lecture, we have covered the topic of exploratory data analysis where we discussed about creating frequency tables, analyzing relationships with two-way tables, calculating probabilities, and we have also discussed about the numerical correlation. In today's lecture, we're focusing on how effective data visualization can help us quickly interpret data, making complex information easier to understand and communicate. We will be exploring basic plot types using the Matplotlib library, which is one of Python's most versatile and widely used libraries for creating static, animated, and interactive visualizations. To emphasize, data visualization is a powerful tool because it transforms abstract numbers into visual contexts, enhancing our ability to detect patterns, trends, and outliers at a glance. This is essential because interpreting raw data through numbers alone can be challenging and time-consuming. To explain why we need to visualize data, as it provides us a quick interpretation, graphical representations make it easier to understand and communicate complex data. It also helps in pattern recognition. Visualization helps in spotting patterns that might not be obvious from raw data. Provides a way to identify anomalies. It's easier to spot outliers or unusual data points through plots than through tables of numbers. Let us now explore the key Python libraries for data visualization. Matplotlib, our primary focus today, perfect for creating a wide range of 2D graphs and plots. Pandas visualization, built on top of Matplotlib, it simplifies creating basic charts directly from data frames, making it a convenient option for quick exploratory data analysis. Seaborn, also built on Matplotlib, Seaborn extends its capabilities by offering a higher-level interface for creating more attractive and informative statistical graphics. ggplot, inspired by R's ggplot2, this library uses the grammar of graphics to build sophisticated visualizations. Plotly, ideal for interactive plots, allowing users to engage with the data more dynamically. We'll start by learning to create the following basic plots using Matplotlib. Scatterplot, useful for observing relationships between variables. Histogram, helps in understanding the distribution of numeric data. Bar plot, great for comparing quantities across different categories. By the end of this session, you'll be equipped with the fundamental skills needed to start visualizing data effectively using Python. This knowledge will serve as a foundation for more advanced techniques in future lessons. So, Matplotlib is a highly capable 2D plotting library for Python that allows us to generate high-quality graphs and figures. Originally designed to emulate MATLAB's plotting capabilities, Matplotlib operates independently of MATLAB but leverages NumPy, which enhances its performance, especially when handling large datasets. Let us start with scatterplot. So, what is a scatterplot? A scatterplot is a type of data visualization that uses dots to represent the values obtained from two different variables. These points are plotted on a two-dimensional grid where the x-axis represents one variable and the y-axis represents the other. In a scatterplot, each point represents an observation. The position of the point is determined by the values of two variables, one plotted along the x-axis and the other plotted along the y-axis. Scatterplots are incredibly useful for examining the relationship between two numeric variables. They can help you visualize how one variable is affected by another, making it easier to identify trends, clusters, and outliers. The scatter plots are often referred to as correlation plots because they can reveal the degree to which two variables are related. By examining the arrangement of dots, you can determine if the variables have a positive correlation, a negative correlation, or no correlation at all. It is also used for the pattern recognition. The distribution of points on the plot can show patterns, such as a linear trend, a tight cluster, or a broad spread, which might indicate variability in the data. Moving ahead, we will create a basic scatter plot using Matplotlib to visualize how two variables correlate with each other. This hands-on example will help enhance your understanding of both the library's functionality and the practical steps involved in creating a scatter plot. In this part of our lecture, we will walk through the practical steps to create a scatter plot using Matplotlib. This will help us visualize the relationship between two variables, such as the age and price of cars in our data frame. Before we begin plotting, ensure that Matplotlib is imported with the common alias PLT. Next, we will set up the data. Suppose we have two variables, age and price. Age will be plotted on the x-axis and price on the y-axis. And to add on, we will not be considering the missing value. As a best practice, while visualizing the data, it is recommended to drop the missing values. So, with drop NA on axis equals 0, we will consider all rows where there are missing value, and with the in-place equals true, as we are not assigning it to any new data frame. After that, the size of data becomes 1096 rows with 13 columns. To create the plot, we use the scatter function from Matplotlib. In this command, age is the data for the x-axis. Price is the data for the y-axis. And the C equals red sets the color of the markers to red. To enhance the readability of your scatter plot by adding a title and labels to the axes using syntax plt.title, plt.xlabel and ylabel. Finally, to display the plot, we use plt.show. This command renders the plot in your Python environment, allowing you to visually analyze the relationship between age and price. Upon executing the code, you will see a scatter plot where the x-axis might show that as the age of the car increases, the price decreases. Each point on the plot represents a data point. The x-axis and y-axis are labeled with tick marks, and the numbers along these axes are called tick labels, helping us understand the scale and range of our data. By following these steps, you can effectively use scatter plots to explore correlations between variables and gain insights from visual patterns. This approach is particularly useful in preliminary data analysis phases where you're beginning to explore relationships within your dataset. Let's refine the discussion and instructions for creating histograms in Matplotlib. This will ensure clarity and engagement for your lecture. A histogram is a type of bar graph that represents the distribution of numerical data by showing the frequency of data points within certain ranges, known as bins. It is particularly useful for illustrating the distribution patterns of a dataset, helping to identify concentration of data points and outliers. So, when to use a histogram? Histograms are ideal for analyzing and visualizing the frequency distribution of numerical variables. They provide a visual interpretation of numerical data by indicating the number of data points that lie in each range of values, which makes them essential tools in statistical analysis, especially for checking the shape and spread of data distributions. Moving on to steps to create a histogram in Matplotlib. Assume you have a dataset cars_data and you're interested in the kilometer attribute to analyze the mileage distribution of cars. So, plt.hist df1 kilometer. This will automatically divide the data into bins and count the frequency for each bin. To improve readability and customization, we can use edge color to add an edge color to separate the bars, and number of bins to adjust the number of bins to better represent the distribution. By examining the histogram, you can infer the mileage distribution of cars. For example, the most common mileage range might be between 50,000 to 100,000 kilometers. The clear separation between the bars, enhanced by the white edge color, helps in easily distinguishing the frequency in each bin. This histogram allows us to visually assess the spread and central tendency of the kilometer readings across the dataset, making it a powerful tool for initial data exploration. Let us now move on to detailed explanation on how to effectively create bar plots with Matplotlib. So, what are bar plots? A bar plot is a graphical representation that uses bars to show comparisons among categories. It displays categorical data with rectangular bars, where each bar's height is proportional to the value it represents. Bar plots are particularly useful for representing frequency distributions of categorical variables, unlike histograms which are used for numerical variables. The key differences between bar plots and histograms. Bar plots separate the bars to represent different categories, which helps in highlighting the discrete nature of each category. Histograms typically connect the bars to show continuous data distributions. When to use bar plots. Bar plots are ideal when you need to compare the frequency, count, or other measure, like mean, across different categories. They make it easy to see relative sizes of features among different categories. For example, comparing the popularity of different fuel types in cars, like petrol, diesel, and CNG. Assume we have data on the number of cars with different fuel types, petrol, diesel, and CNG. This data can be represented as counts for each category. The resulting bar plot clearly show that petrol cars are the most common, followed by diesel and CNG. This visual format allows for immediate comparison and easier interpretation of the data. Today, we've taken significant strides in understanding the basics of data visualization using Matplotlib, one of the most powerful and versatile libraries in Python. We've covered key plot types that are foundational for data analysis, each serving a unique purpose in data science. Scatter plots. We explored how scatter plots allow us to visualize and assess the relationships between two numerical variables, helping identify correlations and trends. Histograms. We delved into histograms, which are crucial for analyzing the distribution of numerical data, enabling us to see patterns and outliers effectively. Bar plots. We examined bar plots, ideal for comparing the frequency of categorical data, which enhance our ability to compare different categories visually. Each of these visualizations serves as a building block for more complex data interpretation tasks, providing clear insights that are critical for informed decision-making in real-world scenarios. What's next? In our next lecture, we will continue to expand our knowledge of data visualization techniques. We'll explore more advanced plotting functions, and plots for statistical representations, and heat maps for complex data correlations. These tools will further enhance your ability to interpret data and convey information compellingly and accurately. Thank you for your engagement today. We look forward to exploring more visualization techniques with you in our next session. Happy plotting until then. We hope that you have found this course informative and interesting. Please hit the like button and subscribe to our channel for more lectures on Python for Data Science course. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course. Thank you for watching and see you again in our next lecture.